Vivian. How was the play?
Oh, it was fun.
Fun?
Good. I got a lot of homework to do though.
What kind of homework?
Well, I have a chemistry project that I'm... Yeah. But it's okay. I know I'll get it done.
What is it?
All the different types of bonding. I'm not sure what I'm gonna do.
Huh.
I can show you what we're learning though. Maybe you'll get an idea.
I don't think so, but still, show me. That'd be great.
Okay, come over here. The first type of bond I'd like to show you is a covalent bond. Covalent bonds are covalently bonded, and they share electrons. A really simple one would just be water, which is H2O. Now, hydrogen has one valence electron. A valence electron is the outermost electron. Now, there's one, but however, there's a subscript of 2, which means there's 2 of them. And as for oxygen, oxygen has a total of 6 valence electrons, but however, there is no subscript, so it's just 1. Altogether, this makes a total of 8 valence electrons. To do a Lewis dot diagram of H2O, we'd start with the oxygen because it doesn't have a subscript. That would be our middle letter. Then we'll have our hydrogens coming off of it. This line is a bond, meaning that they share their electrons. There means that there's 2 electrons there and 2 electrons there. We need to place our other 4, so we'll place them on the O. That makes a total of 8. In order for an atom to be balanced, it needs to have 8 around it, which is what we call the octet rule. So our oxygen is looking pretty nifty. Another type of bonding is ionic bonding. Ionic bonding is different from covalent because ionic bonding uses the ion charge to gain and lose electrons. Now an example for this would be magnesium difluoride, which would be written like that. Now magnesium has an ionic charge of +2, and fluoride has a charge of -1. An ionic charge is how many electrons that an element gains or loses. So to set this up, we'd have our magnesium right here with our charge of +2, and we'd have our fluoride. Now fluoride has 7 valence electrons, and magnesium has 2. Now fluoride only has 7, and magnesium has 2. What ionic bonding does is it'll give 2 to fluoride, but since it already has 8, which it fills the octet rule, we're going to give it to the other fluoride. And it would look something like this. Oops. That's ionic bonding. We also have a few atoms that can't be left alone. They always want a buddy. And these are our little diplomatic guys. And an easy way to remember this is Brinkelhop. Diplomatic just means that they each get a little buddy, that they don't be left alone. And to show this, they each get a subscript of 2. Oops. So, do you understand it now?
I get it now.
Do you have any ideas of what I could do?
Well, maybe you could make a funny movie.
Maybe I could, but I better stop procrastinating this and get my project done.
Okay.
It's in your eyes, a color fade out. Looks like a new transition is starting up and shaking your